Good evening, everyone. I am Sheila Rose Daguhay Quizon. I am the first reporter of Group 2. So my topic is all about sensory contributions of motor control. So as a review, motor control is the regulation of movement in organisms that possess a nervous system. There are two major types of sensory. One comes from the outside of the body and one comes from inside of the body. The first is exteroception. From the word extero, it means outside of the body. It is a perception of external stimuli or objects to perceive body's position or motion. It provides information about the state of the environment in which one's body exists. Exteroception is how you process information about the state of the environment. Therefore, the information becomes from outside of the body. Example of this would be our vision and our hearing. Vision is the ability to think about. We use vision to understand what the direction we're moving as well as how fast and what direction our body is going to space. Addition, which is our hearing, is also key in understanding movement around us in our own movement. Next, we have proprioception. Proprioception, also called kinesthesia. It is the body's ability to sense its location, movements, and actions. It's the reason we're able to move freely without consciously thinking about our environment. Example of proprioception include being able to walk or kick without looking at your feet or being able to touch your nose with your eyes closed. There are many receptors in proprioception. First is the vestibular apparatus. These receptors sense your body orientation, posture, and balance. Another type of receptor is your joints called the joint receptors. These give info about joint position to the brain. These receptors sense of the joint being hyperextended has to provide lemons of movement. Next, located in tendon is called Golgi tendon organs. This sense of level of force a muscle is exerting on the tendon where is connected to the bone. And then, in the skin, we have cutaneous receptors. These receptors contains pressure, temperature, touch, and haptic sense, which is the vibration of your phone when it touch on your body. These receptors send information to the central nervous system or CNS, which is basically your spinal cord and your brain. Central nervous system that the information actually disorganized in a way to understand the body awareness. So, how does the central nervous system process this information and determine what to do about it? The central nervous system processes this information, which is called closed-loop control system. All closed-loop control systems have four distinct parts. First is executive, second is effector, third is comparator, fourth is error signal. First is executive for decision-making about errors. Second is effector system for carrying out the decisions. Third is a comparator, against which the anticipated feedback is compared to actual feedback to define an error. Fourth is an error signal, which is the information acted on by the executive. Limitations of closed-loop control. The inclusion of the stages of information processing in the system illustrate the following. The flexibility in movement control can alter movement based in circumstances. The stages of information processing can be very slow, especially if there's more stimuli or more response that we have. This happens in tasks that involve tracking something and changing quicker in 3 directions per second. This limitation also happen in tasks such as kicking a soccer ball. Tracking tasks are one of the limitations to the closed-loop control system. Tracking tasks is a following some continuously changing target. The system can produce corrections at maximum rate of about 3 seconds. Each correction is based on a collection of information about the past errors. Tracking with more than 3 changes in direction per second is performed poorly. Example is football fumble. Limitation also exists in discrete tasks better performed rapidly. Generally, most rapid actions are initiated in full commitment to the full planned movement. Therefore, the feedback-based control movement is a way to slope the correct rapid movement. Example, the planned movement is very rapid in requiring a full commitment to the full process. If error is detected, the time it takes to process the error feedback is slower than the time it takes. So feedback arising from the rapid movement would not have enough time to be processed before the movement was completed. Most rapid movement must be programmed in advance. The example of this is typing a text message. So, sa imong pag-type sa message, tungod sa imong kapaspas og type, unay usahay nga mali ni mog tuplok ang letter. So, you push the wrong letter before you could fix it because your movement is too rapid. Alright, so moving on. Central nervous system neuron pathway. There are 2 types of neuron that exist. One takes information from the receptors of the body to the spinal cord and brain, and the other takes the information from the spinal cord and brain back those organs of the body. There are 2 types of neuron. First is afferent neuron and second is efferent neuron. Afferent neuron carries sensory information towards brain or spinal cord. The second one is efferent neuron. It sends signals from CNS to muscles to initiate a response to the stimulus. Afferent neuron travel from organ to the central nervous system, and efferent neuron travel from central nervous system back to the organ. So, atong timan-an na ang afferent neuron from organ to central nervous system, tapos ang efferent neuron from central nervous system back to the organ. Proprioceptive reflex exists in the body with the closed loop control bypass information processing stages. Reflexes modify actions quickly, leading to goal achievement. 2 types of reflex exist. First is monosynaptic. Monosynaptic is a transmission of info from a sensory neuron to a motor neuron across a single synapse in the spinal cord. The knee-jerk reflex is an example of monosynaptic transmission. Only one synapse happens between a afferent and efferent neuron. The second type of reflex is multisynaptic transmission. Multisynaptic transmission of info across several neurons and synapses in spinal cord. Additional signals sent to brain to indicate pain and memories. This information is more than one neuron and one synapse in spinal cord to generate a quickly response. The information travels to a higher level of neuron. However, additional signals sent to the brain to indicate pain and memories. It has a stronger response but greater delay. Here are the 2 reflexes. M1 represents the pathway of monosynaptic reflex and M2 represents the pathway multisynaptic reflex. The knee-jerk reflex is the example of M1 and the withdrawal reflex is an example of M2. Alright, let we move on the vision. Our vision occurs as a very important activities. Vision is considered as a exteroception and not a proprioception. Visual information is delivered from the retina of the eye along 2 separate processing streams to different places in the brain. 2 separate processing pathways to the other different places of the brain. These 2 pathways is dorsal and ventral stream. The first pathway is the dorsal stream. This portion determines of answer the question, where is it? The other pathway is the ventral stream. This portion determines or answer the question, what is it? Again, the ventral stream is a processing pathway that is used for conscious perception of objects, and because of the consciousness, this stream processed through the information processing stage. Ventral stream focus on the specific object and identification. The dorsal stream is specialized from movement control, is it involved the entire visual field. This stream is considered as a non-conscious. Okay, so this concludes the lecture of sensory contributions of motor control. Thank you for listening. God bless us all.